Alright, at the new Mount Cubic ski resort, a developer, Mr. Wang, noted that the cross-sectional shape of Mount Cubic and the adjacent Mount Infinity could be modeled by the function f of x equals a half x squared times x plus 5. Coordinates are measured in units of hundreds of meters. Find f of 3. Well, that should hopefully be straightforward. F of 3 is equal to a half times 3 squared times 3 plus 5. A half of 9 is 9 on 2 times 8. 9 times 8 is 72 divided by 2 is 36. Find x when f of x equals 0. So what we're saying there is a half x squared times x plus 5 equals 0. We can immediately use the null factor law because we know either this equals 0 or this equals 0. So that leaves us with either a half x squared equals 0 or x plus 5 equals 0. That's a 5, believe it or not. So x equals negative 5. Or in this case here, the only x value that would work so that make this equation true is x equals 0. So x equals 0 is an x-intercept and x equals negative 5 is an x-intercept. We can see that on this graph here. So the red line is the equation f of x. And we can see that it has an x-intercept at negative 5 and at 0. Okay, use calculus to find all stationary points and show their nature by drawing a sign diagram. So what that means is, on our original equation here, we're going to have some maximums and some minimums. But on your test, you don't have this picture here. What this question is asking us to do is to find out the turning points and determine whether they're maximums or minimums, or maybe points of inflection. So what we're going to need to do that is we're going to have to differentiate it. Before we can differentiate it, we have to expand it out so that we can do it more easily. Otherwise, we have to use the product rule. So what we're going to say is we expand it out, so we get a half x cubed plus 5x squared. Okay, now f dash of x is going to be equal to 3 on 2x squared plus 10x. Have I done that right? 3 on 2x squared plus 5x. My bad. So this part here, as I expand the half in, should be 5 on 2x squared. Alright, so f dash x equals 3 on 2x squared plus 5x. That's better. Alright, then what it wants us to do is to, first of all, find the stationary points. So to find the stationary points, we let the derivative equal 0. Okay, if we let the derivative equal 0, how are we going to solve this? Well, we can take x out as a factor. That would be a good idea. We'll be left with 3 on 2x plus 5 equals 0. Okay, then from there, we can use the null factor law. So either x equals 0 or 3 on 2x plus 5 equals 0. Solving this for x equals, we'd subtract 5 from both sides, you'd multiply by 2. This would be at negative 10 divided by 3. So that's negative 10 on 3, which is shown up here to be negative 3.333. Just so you have a bit of a sense of how big the number is, negative 3.3 recurring. Okay, then what it wants us to do is to show the nature. So at this x equals 0 and x equals 3 on 2 x. So at x equals 0 and at x equals negative 3.3, determine the nature, so whether it's a maximum or a minimum. So the way we do that is we set up a sign diagram. So let's do 2 sign diagrams. So one, we're going to set it up like this, and there's probably more steps here than is probably necessary, but let's do it anyway. Sign diagram looks like this. So in here, so we have our x value, and then we're going to say what's the sign of that, so whether it's positive or negative is going to go in this row, and then slope is just going to give us a picture of what that looks like. Okay, so we know that 0, let's do 0 first. We know that at 0, at x equals 0, our derivative equals 0, because that's what we've set. So we know that f dash of x at x equals 0 is 0, because when we solved our derivative equaling 0, we got x equals 0 as a solution. The sign of 0 is just 0, it's not positive or negative. And the slope of that, well, what would that look like as a sort of a line? Well, a line with no gradient would be a horizontal line. Okay, then what we do is we pick a number to the left and then to the right of 0. So let's say x equals negative 1. Now, in a different color, let's quickly work out what f dash of negative 1 is. We're not really interested in the number and the answer. We want to know whether it's positive or negative. F dash of negative 1 is equal to, so it's 3 on 2 times negative 1 squared plus 5 times negative 1. Okay, so that's going to be 3 on 2 minus 5 equals, well, 3 on 2 is 1.5. All we care is that it's negative. Okay, so we're going to say we know the sign is negative. For wholeness, let's just say 3 on 2 minus 5. We know that's minus 7 on 2. But all we're really interested in is what's the sign of that. Okay, so what does a slope that is negative look like? Well, a negative slope, just from our linear algebra, goes down like this, doesn't it? Good. Alright, then we pick one to the right of 0, so let's pick positive 1. Okay, let's do that quickly, and I'll rub this out. So it's going to be, oh, that's annoying. Let's just do it the shortcut way. Alright, so that's got to be a 1, so we're saying f dash of 1. So it's 3 on 2 plus 5 this time. So 3 on 2 plus 5 is 13 on 2. So f dash of x is 13 on 2. We know that's positive, and we know that a line that is positive slopes up like this. So from the slope, we can see that our line has to go like this, and then it goes down like that and like that, aka it is a minimum. Alright, we play the same game over here at this point. Now I'm going to get rid of the f dash of x value. We're just going to think about whether it's positive or negative. So we're going to say our x value, we're going to say the sign of it, and then we're going to say the slope of it. Okay, so at x equals negative 10 on 3, okay, what's that? Well, we know that the sign of that is going to be 0, because our f dash of x value is 0, so our gradient function is 0 at negative 10 on 3, so we know the slope of that is 0, so we know that that line is like that. Okay, negative 10 on 3 is roughly around, yeah, is negative 3.3 recurring, so let's pick a number to the left of that. Let's say negative 4, and let's work out what that is. So it's f dash of negative 4 is equal to 3 on 2 times 4 squared plus 5 times 4. Well, 4 squared is 16, 3 times 16 is 32, 48 divided by 2 is 24, plus 20 is 44. Anyway, the point is that it's positive. The sign is positive. So this is at -4. And let's do at -3 because that's to the right of this point. Okay, well that should be let's see if that's positive or negative. Well, that is, so that's a -3 in there now. That's a -3, that's a -3. Okay, so 3 times -3 squared, well, that's 3 times 9, so that's 27 on 2, minus 15. That's equal to 27 on 2 is, well, half of 28 is 14. So this is a negative answer. So we say this here is the sign is negative. Okay, now the slope. Well, the slope for a positive, the slope for positive is like this. And I stuffed this one up before. And slope for negative is like that. So i.e., a graph looks something like this. The gradient changes in this fashion. So it is a maximum value. So this is minimum, and this is a maximum. So at x equals 0, we have a minimum point. Good, that's what we determined. At x equals 0, it's a minimum. At x equals -3.33, it is a maximum. So we can use these sign diagrams to determine that information. Okay, part D, sketch f of x and label the following features. If I tried to sketch it on the computer, it would not be pretty, so I've just done it on Desmos and label the following features. Alright, so the car park is at the origin. So this here must be the car park. The sum of Mount Cubic is at a stationary point M. Yep. So that must be part 2. Mount Cubic cuts the x-axis to kiosk at the bottom of the mountain. We determined earlier on that this was at the point -5, 0. So that must be where the kiosk is. And Mount Infinity is where f dash of x is greater than or equal to 0 and x is greater than or equal to 0. So the first part says f dash of x is greater than or equal to 0, so the gradient is positive. So we have to look for anywhere on the graph where the gradient is positive. Well, it's definitely not in here because the gradient between the maximum and the minimum is sloping down, so it's a negative gradient. It's a positive gradient over here because it's sloping up, but our x values are negative. So Mount Infinity, as you might guess, is this stuff over here. Because a gradient is positive and it's greater than or equal to 0 at that point. Sorry, our x values are positive there or equal to 0, and our gradient is positive there. So Mount Infinity, obviously, it goes on forever, and hence the name. How high is Mount Cubic to the nearest meter? Okay, well, we have to remember earlier in the question, it said coordinates are measured in units of hundreds of meters. Okay. So Mount Cubic must be, well, it's 9.259 units on here, but that has to be in hundreds of meters. So it has to be 926 meters. Mr. Wang decides to build a linear chairlift from the car park to the point -39. -39, okay. 1, 2, 3, -3, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's there. Just below the summit. from the car park. Okay, find an equation of the chairlift. Well, that should be reasonably straightforward. We know that it's a linear, so y equals mx plus c. Okay, the gradient. Well, to find the gradient, it's y2 minus y1 over x2 minus x1. Okay, so our y values are 9 minus 0 over negative 3 minus 0. 9 minus negative 3, 9 divided by negative 3, I should say, is negative 3. So we know that y equals negative 3x plus c. All we need to know now is our y-intercept. Now, I could substitute in our y values, y and x values here to find c, but I know that the line cuts through the origin. So that means the y-intercept is 0. So this just must be y equals negative 3x. What would the chairlift cost to build at $10 per meter to the nearest dollar from x equals negative 3 to x equals 0? Okay, essentially what that question is asking is the length of this line. The length of this line so the length of a hypotenuse of a triangle with the height is 9 and the length is 3. So let's do that. So that will be, let's do a little diagram. This is 9, this is 3. We know using Pythagoras, c squared is equal to a squared plus b squared. C equals the square root of 9 square root of 3 squared plus 9 squared. Square root of 90. Simplifying surds, the square root of 90 is the same thing as the square root of 90 is the same thing as this 9 times 10, the square root of 9 times 10. Well, that's equal to this 3 root 10. Okay. Remember, we have to multiply everything by 100. So, length of lift equals 300, because we multiply 3 root 10 by 100 meters. Alright, we keep everything in exact form until we have to round, so we keep it like that for now. Okay, and then it costs $10 per meter. So again, the cost is just going to be equal to, we just have to multiply by 10, so it's 3,000 root 10, and that'll be in dollars. Alright, then we have to round that to the nearest. 3,000 times root 10 is equal to $9,486. $87. To build another chairlift, lift 2 from the kiosk from k equals negative 5 and 0 along a route that intersects lift 1 and Mount Cubic at the point P. Alright, since this is all a calculated test, lift 1 and Mount Cubic from the previous question, I'm just going to tell you, is negative 2, 6. So the sum line that goes through the kiosk and goes through this point. Okay, if we know that, then we know that the gradient is equal to y2 minus y1. So let's do 6 minus 0 divided by negative 2 minus 5. Okay, so we got 6 minus 0 is 6 divided by negative 2 plus 5 is 3. So our gradient of that is 2. So we know y equals 2x plus c. Okay, then we substitute in some coordinates. Let's use these ones here, because we know if we substitute an x and a y value, we can find our c value. So we're going to say 6 is equal to 2 times negative 2 plus c. So c equals 10. And then our whole equation is y equals 2x plus 10. Alright, nice. Show that the equation to find the coordinates of the point P is given by that. Okay, the equation of point P is where lift 1 intersects Mount Cubic. So Mount Cubic was, what was it? A half x squared times x plus 5. So a half x squared times x plus 5 is equal to, the previous line is equal to lift 1. Lift 1 was minus 3x. Okay, now we need to rearrange this so that it looks like the way they want it. So let's go a half x cubed, expanding everything on the left, plus 5 on 2x squared, plus 3x equals 0. Alright, the tricky part about this is we can scale everything up, and this is what they want you to recognize. If you notice here, every term, every coefficient can just be scaled up. If you don't believe it, that can be done without changing the graph, just have a look at Desmos and sketch both of these things, but we can scale all of these coefficients up. So it becomes a half times 2 is x cubed, so we're multiplying everything by 2 to get rid of the halves. So it's x cubed plus 5x squared plus 6x equals 0. And then as required, or whatever you want. Hence find the coordinates of P. Okay, well that just is a calculator question. I don't know how you could have done this question. I don't like the order of these questions, is what I'm getting at. Hence find the coordinates of point P. Your calculator will solve that for you. It's negative 2, 6. Find the equation of the line KP. We already did that. That's y equals 2x plus 10. I think this is a typo. I think this should have been lift 1. Anyway, you can think about that. Find the angle PK makes with the x-axis. Okay, this is the point P. This is the point K. Wants us to find this angle here. Okay, well, how are we going to do that? Well, let's think about this. The gradient of this line, this black line, is m equals 2. Now, what does that mean? Well, that means it's our rise over our run. And remember, gradient is a measure of your rise over your run. So we know that our rise over our run, so whatever the ratio of this length is to this length is 2. Now, thinking of a SOHCAHTOA, tan of some angle is equal to the opposite, so this side here divided by the adjacent side. So we can say tan of the angle that we're interested in is equal to, well, this divided by this, opposite over adjacent, is just 2. So theta is equal to, I think that's 60 something degrees. So let's tan inverse of 2. So theta equals tan inverse of 2. Just so we're clear. And that's equal to 63.4 degrees. Okay, find the coordinates of point Q. Okay, I didn't mention before, but this graph is what your graph on your calculator should start to look like. To find the coordinates of point Q, it's just 2x plus 4. Sorry, 2x plus 4, 2x plus 10, which is our black line, is equal to the cubic, which is a half x squared plus 5x, I think it was. It's not right. So it's a half x squared times x plus 5. Alright, set them equal to each other. You'll get a quadratic. You'll solve it just like we already did here. And there was another solution to this one here, to this thing here. There's another solution to that. So, and it'll be at the point 214. I don't like how that question was set out, but hopefully you get the gist.